Okay, welcome back. This is part 2 of the Unit 3 and 4 review. Now, I had a good question after I paused the video. It says, how do you find the charge? It's one of those things that you're going to have to remember, that the charges are associated with certain columns and groups in the periodic table. You're going to have to know where they're at. It's just one of those things you have to memorize. If, for whatever reason, the periodic table that is in the classroom does not have it labeled. And so one of the easiest ways and things to remember is that if you know their valence electrons, you got to figure out which place is easier to get to 8. So over here, this is +1, +2. But the other way to think about it, this is 1 valence electron, 2 valence electrons. So this one has to lose 1 valence electron. This one has to lose 2 valence electrons to become stable at 8. Over here, it's +3. This one is ±4. So it can either gain 4 or lose 4 to become stable. And then over here, these are all the nonmetals. So they want to become stable, so they're going to gain electrons. Now remember, an electron, as I just said in the last part, an electron has a negative charge. And so if you gain a negative charge, you're becoming more negative. All right, go back to your number line and your math class if you're confused by that. All right, moving on. Let's look at Lewis structures. This is mostly review for people. Some of this might be brand new. If it is, find some videos on YouTube. That's the only thing I can really tell you. We're going to do about 4 of them. So with Lewis structures, you're going to write the element symbol. I'm going to abbreviate that SY, and then you're going to surround it by the valence electrons. Okay? So sodium is what? Na. Now, how many valence electrons does sodium have? It has 1. So you might do it differently in other classes, but in mine, the way I like to tell you guys, is you start off at the 3 o'clock position, and then you work your way clockwise. So if we look at silicon, the symbol is Si, and it has 4 valence electrons. So we do 1, 2, 3, 4. We don't start pairing up until the very end. Once we hit 4 and we start working our way around again, that's when we start to pair up, because those are what we call a lone pair of electrons, which means that you can't bond at that site. We'll get into what that means more in our next unit, but for right now, just know that. So with sulfur, it has 6 valence electrons. So I'm going to do 1, 2, 3, 4, 5, 6. So right here what this says is that I have 2 lone pairs of electrons. What that means is that no bonding takes place there. So that's part of the reason why sulfur has a -2 charge, because it is depending on another atom, like say magnesium, to come in and donate its 2 valence electrons. If you don't understand that, don't worry about it. It's not that important. That's for the next unit. Let's look at bromine. It has 7 valence electrons. So with bromine, we're going to do 1, 2, 3, 4, 5, 6, 7. So bromine has a -1 charge because it only needs to take in 1 more valence electron. Any questions? All right, good. If you have questions at home, like I said, just do a YouTube search for how to fill in Lewis dot structures. All right, so right here, periodic trends, we're going to skip this because what I want to do is go into actually talking about the periodic trends first. And then, so let's do that. We're looking at number 11. All right, so number 11, where are nonmetals found on the periodic table? All right, they are found, so this is a little bit off. So over here is the nonmetals. That is my awesome view of a periodic table, just so you know. And over here are the metals. The elements touching the zigzag line are what? Metalloids. All right, so they're metalloids, with the exception of aluminum. All right, what is which of the following groups in the periodic table is the least reactive? D. Okay, group 18. Why? Okay, they have a full valence shell, meaning that all of their outer electrons are completely filled up. All right, so next part, define the 4 factors that cause periodic trends. Anybody want to take a stab at that one? Nobody? Oh, thanks. All right, it's the pull of the nucleus on the electrons. So it's the pull of the nucleus on the electrons. Let me do that. Okay. So basically what that's saying is that you have your nucleus, which is in the very middle of your atom. So the nuclear pull is how much exertion that nucleus can put on the electrons, both outer and inner electrons. Electron repulsion. Anybody want to do that one? This is the point where if you're at home, you find these notes. That way you don't have to waste time on them. Okay, so electron repulsion is the electrons push away due to the same charge. This is more evident as you go down the periodic table because you're having more electrons that are there. Your nuclear pull also decreases as you go down a group because of this thing, the electron shielding. Basically, it's the inner electrons of the inner electron shielding of the nucleus. I completely misspelled that one. Let me scroll down there. Okay, so the inner electrons shielding of the nucleus from the valence electrons. So if you look at it, again, as you go down the periodic table, you have more protons, more neutrons, more electrons. But the problem is as you go down, so if we look at group 1 on the periodic table, the nuclear pull is not that strong because we have a lot of shielding electrons that get in the way. As you go down the periodic table, you're getting more protons, but you're keeping with the same number of shielding electrons. So as you go down the periodic table, a lot of things happen. They do different things. So if we look at atomic radius, which is basically how big the size of an atom is, when we look over here, as you go down, what's happening is the nuclear pull is increasing, so that causes the protons to pull more on the outer electrons. As you go down, what occurs is you're adding more shielding electrons, so your nuclear pull actually decreases as you go down the periodic table. So look at the first group on the periodic table, starting with hydrogen. What happens to the size of the atoms as you move down to cesium? What do you see? It gets bigger, okay? And it gets bigger, bigger because, again, if you don't know this abbreviation, B/C, just because the nuclear pull, NP, decreases due to more electron shielding, ES. That's what we're going to call it. So the nuclear pull decreases due to more electron shielding. Okay? Questions? Yes, sir.
Why on the table over there on the very last row, VI has a smaller atomic radius than CO?
Okay, so right here, this is in general. In general. As you go down, they get bigger. As you go from left to right on the periodic table, they get smaller. Unless we give you a number, a specific number, we will ask in general which one's bigger, which one's smaller. Okay? So that's the trend that you need to know. That over here is the biggest, and over here, with the exception of hydrogen, it's the smallest. And so the trend goes like that, where it increases that way. So that's what we're expecting you to know. So as you move towards francium, which is down there at the bottom left, you get bigger. That is what we're expecting you to know, unless we gave you a number, of course. All right, I'm going to pause it right here, and then I'll pick it up on question 16.